So this video is on Friday, December 18th classwork. This is the scatter plot that was the car skid marks and the speed of the car. So just so everyone understands, whenever you have this, this first column here is always going to be your X. And this one over here, on this side is going to be our Y. Okay, so this is your X and this is your Y. So when we are putting this on a graph, this is all going to be our X. This is going to be our X axis. This is going to be our Y axis. These points are 5, 10, 17, 20, and so forth. Now what we're going to do is we're going to do a scatter plot on Desmos. So I've got Desmos opened up here, and I want to add an item. So I'm going to come here to this plus, and I'm going to make a table right there. And then I'm going to put in my values. So 5, 17, I'm just going to go down. 37, 65, 105, 150, 194. And then I'm going to put in my Y's. So, and let me here, I'm going to make this a little bigger. Okay, so I'm going to put in my Y's, which is 10, 20, 30, 40, 50, 60, 70. And then it's going to be plotted here. Now, we can zoom in and out, but sometimes your x-axis is scaled, needs to be scaled maybe further out or less than maybe your y. So in this case, you'll notice that our x's go to 194 and our y's only go to 70. So I'm going to come over here to the wrench. I'm going to come to the x-axis and I'm going to change the scale. I'm going to go from 0 to 200. Okay, I want to go a little beyond my 194. And on my Y, I'm going to go from 0 to, let's say, 75. So I'm a little beyond that. And then you just click the wrench off. And here's your graph. Okay, so you can see that it is an increasing situation. You can see that it is going to follow like a linear regression. So what we're going to do next is we're going to do a line of best fit. And to do our line of best fit, I'm going to come here and you can also probably do this from your keyboard, but I'm just going to get the keyboard up here. We want to type in Y1, okay, Y1, because we want the Y values from our table. And instead of an equal, if I come here to the ABC, right here, this symbol in math is similar. That's the symbol we're going to do. I'm going to do MX1 plus B. And the plus B, got to add the plus B in. Okay. And so now you see the line. You see the points don't go exactly through, the line may not go exactly through all the points. It may go through none of the points. Okay, it doesn't have to go through all the points. It's the line that best follows the data. So if I'm looking here, I see this M, that is my slope. So it is about a 0.3. I see this B, this is my y-intercept, it's about a 15.5. So I'm going to come down here and I'm going to type it in, y equal 0.3x plus 15.5, and you see that it does go through those points. So now what I'm going to do is I am going to take this graph and put it onto my Cami. So I'm going to come up here, hit share graph, export image. I think I'm going to change it to thick so it's a little bigger, and download. Now mine's going to download to my download on the Chromebooks. It's probably going to download to your Chromebook. And then what you're going to do, let me come here and make this bigger. You're going to come over here to add media. Okay, go to computer. Yours is probably under images, maybe under your Google Drive. Mine is going to be under downloads. It's right here. And there you go. And then I can extend it and make it bigger. And there's my graph. Now I am going to come and label my X and my Y axis. So I'm gonna grab a text box. I'm gonna come here and I am going to type in what my X is, which is the length of a skid mark. So I'm gonna type in length of skid mark, and I'm gonna put in parentheses feet. And then I'm gonna do the same over here, and this is gonna be speed of the car in miles per hour. Okay, so click here, and I can go like this, and up here I'm changing it by hitting this rotate. Okay, so that's normal. There, that's going to be where it's going to write where I want it to, like on the side here. So this is going to be speed of car. Here, let me get it to be bold. Speed of car in miles per hour. Okay, so speed of car in miles per hour. So again, when I'm in my text box, if I come up here to the top, there is this, this button right here, rotate, that I can push. Okay, so now I am going to describe the scatter plot. And these are using the sentence frames. I'm going to get the sentence frames up here also so you guys can see them. So on this side here, I have the describe the scatter plot. There is a strong or weak, positive or negative, linear or nonlinear relationship between. And then here where it says X variable, you're going to put what the X is representing and what the Y is representing. So I am going to write, there is a strong, points are very close to it. Let me move it down so we can kind of see the graph. Positive because it is increasing. Linear relationship between the length of a skid mark and speed of a car. Okay, and that is what you're going to type in for a describe the scatter plot. Now here on this one, the original one, they gave us this, okay? We put in the data and we ended up with a slightly different line of best fit when we generated it. So I'm just going to put here what our line of best fit was. And our line of best fit was y equal, so let's use that one, 0.3x plus 15.5. Whoops, plus 15.5. And that was our line of best fit that we got. So that's the one we're going to use. Okay. Now we have the line sketched here. So we have that there. Next one is interpret the slope. Okay. So interpret the slope. Interpret the slope is right here. Interpret the slope. And it says as the X variable increases by 1, and this it says whatever the X variable unit of measure is, then, let me move it over a little bit, shrink it down slightly, then the Y variable decreases by about, and then we're going to put that in here. So again, I'm doing the slope. And so what I'm going to do first thing I'm going to do is I am going to trying to see if I had a, I guess I don't have a pink. I'll write it in pink maybe. Trying to color code. I guess those are the only color options. Okay, I'll just keep it with the yellow highlight then. Okay, so interpret the slope. So slope equals, and in this case, our slope for ours was 0.3. And then what we're going to do is we are going to write the sentence frame. So the sentence frame is as the, and our x variable is length of skid mark increases by 1, and the unit is foot for this. And our y is represented by the speed of a car, and then you have to look at your graph, decide if it's increasing or decreasing, and it's an increasing, so increases by 0.3, because that's our slope, miles per hour. Okay, get all of that to be black. Okay. Now for the interpret the y-intercept, okay, interpret the y-intercept, it says here for that, when the x variable is 0, the y variable is about blank. So for this one, let me just get my fill here. So my y-intercept for this is 15.5, and I'm going to write it as a point. This is 0, 15.5. So the 0 is going to be the x, which is talking about the length of the skid mark, and the y is going to be the 15.5. So when I write my sentence frame, I'm going to say when the, and my x is length of, when the length of the skid mark is 0 feet, the, and this is our y, speed of the car is 15.5 miles per hour. Okay. Predict the speed of the car if the skid mark measures 105 feet. So always when they say predict, okay, let me just grab something to write with. Always when they say predict, this word predict, even if they don't say use the equation, that's what you use. You always use your equation. Prediction is from your equation. It's not from your table. So I'm going to use my equation. And again, my equation was y equal 0.3x plus 15.5. So I'm going to be putting in 105, which is my skid mark. That's my x. Okay, it's going to go in for my x. So I'm going to go y equal 0.3 times 105 plus 15.5 plus 15.5. And when I put that into my calculator, I end up getting a 47. This is 47 miles per hour. Okay, so my prediction is, so my predicted speed is 47 miles per hour for a skid mark of 105 feet. Okay. Now, this predicted is going to come into play when we talk about residual. So I am going to add a page on, and I am going to talk about residual. Okay, so let me get a text box. Residual is equal to, capitalize it, residual is equal to your actual, and when I say actual, this is from your table minus predicted, and this is from your equation. Okay, so again, it's actual. Let's see if I can change that. Actual minus predicted. Okay, that is what residual is. So if I want to find the residual for 105, to find the residual for a skid mark of 105 feet, what we're going to do is the following. We're going to look at the table to find what speed corresponded with 105 feet. So when I come up here to my table, here is my 105. Let me circle it. A little thinner. Okay, so here's my 105, which is 50 feet. Okay, and that particular value is right here on my graph, and here is where it is on the equation. Okay, so you can see that it is more actually than what we predicted on the line. But again, this right here, 105, that's going to be our actual value, 50. Okay, so I'm going to come back here, and for residual, again, I'm going to take my actual, which is 50, minus my predicted, which is from my equation that we just found in the problem above, and that is going to equal 3. Okay, so we are off by 3 miles per hour. So what that residual means is our prediction, well, I'll say it this way, the actual speed of a car with a skid mark of 105 feet is 3 miles per hour more than our prediction. So again, we predicted it was 47, the actual was 3 more. So that is positive. If our prediction was more, then we would have ended up with a negative residual, okay? But in this case, the actual was more, so I take actual always minus predicted to get your residual. Now, the other thing I was showing us in class is how to get the residuals, a residual plot. So let me show you guys that. So if I come over here, okay, and really it's going to be here, usually spaced out more, where it says residuals, has a little E1, and I click plot, what's going to happen is it's going to plot all of the differences being from my data point to my line. And it's going to plot those above and below the x-axis. So when I hit plot, you see them being plotted above and below. You also see all of those residuals are given right here. So the residual for a skid mark of 5, the actual was 10, which is 7 less than what we predicted. So we predicted it would be about 17. Okay. This one here, 17, length of a 17-foot skid mark. Actually, it was 20. That was about a little less than 1 from what we predicted. So all of these are those residuals. Now this one right here, this 105, 50, that gives us this 3.087. Again, ours was 3 because we didn't round, we rounded, they aren't rounding. So ours was rounded, okay? So ours was not exact, was 3, theirs was not exactly 3. In terms of the actual graph, here's your residual plot, okay? This is the residual plot right here. These ones in blue is our residual plot. So I'm going to share this graph, and I'm going to download it. And then I'm going to come over here and I'm going to add it on to this. And above it, I'm going to say, for mine, get it out of the highlight. The blue points on mine is the residual plot. So the blue points represent the residual plot. We are plotting for each data value how far off our prediction was. That's what we're doing. Okay. So again, that's this blue right here. The other thing I just wanted to mention in here, okay, you don't have to add it onto your paper, but just for those of us who want to understand, this is something we're going to be doing soon enough when we get back from break. This R here is your correlation coefficient. And your correlation coefficient is how strong your graph is. Okay. So I had shown us the other day, and I showed us again today in class, kind of what that meant. So I just pulled this up. So when we're talking about our correlation coefficient, it's between 1 and -1. And 1 means every single point on our positive graph is on our line. And -1 means every single one of our data points is on our line, but it's negative. As we get the points further and further off the line, you see the numbers are getting further and further away from 1 and -1. And so it's not as strong the further it's getting away. Now, in this case, when we have an R of 0.98, that is strong. That's very strong. So we're going to end up so again, when we're looking at this R, which is 0.9804, that is close to 1, okay? And so that is a strong correlation coefficient. So I am just going to actually snag this here. Let me just copy this. Okay. And I can put it on this. So now let me come back to this. And so what I want to add in, again, this is a little extra, so I just want to have this in the video for those of us who want to kind of get a head start on things, and or just have something to look back on when we get to this in our class. The R, that is our correlation coefficient. So we have interpret, okay, and that I have right here. Let me click over to this. Let me get rid of this for a second. So again, on this correlation coefficient, let me get to it. Okay. So here is interpret the correlation coefficient. Let me just get this on the screen, sorry. Okay, so this one here is our sentence frame for interpret the correlation coefficient. Since R is, and we're going to state that R that I just kind of took a snippet of, and is close to or far from 1 or -1, there is a strong or weak, positive or negative linear relationship between the X and the Y variable. So once I say the since R equal is close to or far from 1 or -1, the rest of it is basically like our describe the scatter plot line. Okay, so let me come back to here. I'm just going to make it slightly bigger. And I'm going to fill it. Okay, so interpret the correlation. And I'm just going to get that little snippet here. Okay, so that was our correlation coefficient, so I can see it. I'll move it over here. Okay, so since R equal 0.9804, and you'll give the whole entire number for that whole 4-digit after the decimal number. And then we're going to say is close to or far from, but this is close to +1, okay? There is a, and because of that being so close to +1, there is a strong positive linear relationship between, again, the X, which is the length, doing that, the length of skid mark and the speed of the car. Okay, so this kind of covers everything we're going to be needing to know about the line of best fit, how to do a scatter plot, how to do a line of best fit on Desmos, how to write all of our sentence frames, okay, which is in our notes. Okay, so hopefully you find this helpful. Have a nice break.